Hi, welcome to this paper. It's a predicted paper for the non-calculator in May 2025. It is based on our knowledge and experience of past papers. So no one can tell you exactly what is going to be in your paper, but what we can do is create something that really pulls together the most common things that we see. Now, I have written these questions so they are new. They are not a mashup of other past papers to create this, which makes it a great revision resource because you haven't seen any of these questions. So it will really test your understanding and your knowledge of the maths. So you can download the paper, it's in the description, and you can either set it like a mock, do it quietly, come back to the video, or you can work along with the video, entirely up to you. Please also be aware that the channel has lots of past exam questions that have been created with worked solutions and then grouped by grade. And we also have that for grades 1 to 2, 3, 4 to 5, literally all the way through. So do go and check that out if you want to do a bit of revision, but you don't want to do hours of it. You haven't got time with all the other things going on. Then a quick 10-minute here or 20 minutes there in these playlists is fantastic revision. It really is. I will be creating something for paper 2 and paper 3. So if you have found this useful, please like, please subscribe, and keep an eye on the channel so that as they land, you will be able to find them nice and easily. All right, let's get on with this particular paper. Okay, so this is the first question of our higher paper. Now you're going to notice that these first few questions don't have the same numbering. That is because they're the crossover questions, and these were the numbers for our foundation paper. I recorded the foundation paper first, so the numbers will be out of sync. All right, but don't let that put you off. Okay, we're being asked to write 240 as a product of its prime factors. So we're going to split and write down two factors. Now, how you split and the two factors you use may be different to me, and that's absolutely fine. We all see things differently. There's no right or wrong way here. I'm going to do my 10 next because I can see it's nice and small. It's going to go straight to some prime factors and I can be done and dusted with the 10. Now, 24 is going to be 8 and 3. And I've got another prime factor. You may do 6 and 4. As I said, it does not matter. And then for the 8, I've got my 4 and my 2, and then my 2 and my 2. And I have 2 to the power of 4 times 3 times 5. Now we're being asked to find the highest common factor of 240. So it's the same number as the first part and 112. So we're going to use the then method for this. To do that, I am going to need the factors of 112 as well. So I'm just going to quickly work those out. And from above, I could see that the 8 went to 3 2s. So this is my 112. This is my 240. I am going to match in to the middle any that are common. I'm also going to list these out so that I can see them really nice and clearly. I won't relist these because I can see those already. So this 2 can pair up with that one. And I'm going to keep going until I have bound them all. There is no 7 common and there's no 3s and 5s common. So that's completed. Now, technically, I didn't need to complete it because the highest common factor is actually just the middle section here. So that is 2 times 2 times 2 times 2, giving us a final answer of 16. I filled it in completely just so that I could remind you that if it had been an LCM question, you would be expected to multiply all of the sections. Okay, we've got the first 5 terms of an arithmetic sequence, and we've got to write the nth term. So we need to see what it's going up in. To get from -8 to -2, we add 6. And if you're not comfortable or confident with your negatives, you could always go up to one of these positive ones and double check to see if that's still working. The gaps, the number that you find by looking at the gaps, is the number you squash to the n. Now we're going to do the opposite. We're going to go to that first number, go in the opposite direction, which means we're going to end up taking away 6. -8, go down another 6 places, and you are at -14. And that is the part that goes on the end. I see lots of students sort of muddle between the two. So gaps are squashed, and then that last step is the last thing that you write down. Okay, we're being asked to reflect the shape in the line y equals -1. So job number 1 is to put that on. This is my y-axis. My -1 is here. That's just a point, which is not a line. The line goes through that -1. And then we reflect. Now, you can use your tracing paper here. If you were to use your tracing paper, you lay it completely over, trace your shape, trace your line, and make sure you put a marker on it. I have a video, actually, I'll get it so that it pops up on the screen now, that shows you how to use the tracing paper for these types of questions. If you're not, you can do the count method, which works on horizontals and verticals, where you just say, okay, that corner is 1 away, so my new shape will be 1 away. This is 2 away, so my new shape will be 2 away. So you work out where it all goes, and then you can draw it in. And I've done it quickly. You, I hope, would use a ruler. Okay, we've got a pretty big question going on here. The area of the triangle is equal to the area of the rectangle. Work out the difference between the perimeter of the rectangle and the triangle. So I've got to do a little bit of work using my knowledge on area before I'm going to be able to answer the question. If I'm going to find the difference between the perimeter, then I need the perimeter of both shapes. At the moment, I can't do that, because I don't know what this edge is, and I don't know what this edge is. I'm going to need to work out what x is so that I can go on and find out this edge and then go on and answer the question. So the first line is what is going to help me. They're saying that the area of the triangle is equal to the area of the rectangle. Now, the area of the rectangle is base times height. So it's going to be 10 times 3x, which is 30x. The area of my triangle is base times height. So that is going to be 15 times, and then the height, which is 2x plus 4. Now, it's all of this that has to be multiplied. So you're going to times the 2x by 15 to get 30x, and times the 4 by 15 to get 60. And then you divide by 2 because it's a triangle. So that's going to lead to 15x plus 30. They're telling us that these two areas equal each other. So the area 30x of the rectangle is equal to 15x plus 30, the triangle. Bring the x's together by moving the smaller set of x's. So I'm going to hop that over. It's going to land as negative 15x. And now I've got 15x equals 30. Divide through by your 15, and you've got x equals 2. Now I'm going to substitute that 2 into the algebra on these edges so that I can work them out. So 3 times 2 means that this edge is 6. And 2 times 2 plus 4 means this edge is 8. I can now work out the perimeters of these shapes. So the perimeter of the rectangle is 6 plus the other 6 plus the 2 10s, which is giving me a total of 32. And the perimeter of the triangle is your 8 plus the 27 plus the 15. You may need to put these in columns, or you may be just fine. That equals 50. The difference between those two is 18 centimeters. Okay, so we're being asked to complete the Venn diagram. The symbol here just means that this is everything that needs to be included. And in this question, it's all the even numbers between and including 20 and 40. Now, the first thing I do is write them all out. That way we can cross them off and make sure that we've got everything that we want. I'd also write out the multiples of 4. And then we want to pair up and get the middle section done first. So I can see that 24 is in both sets. I can see that 28, 32, and 36 is. And then I would cross those off my main list as well. So 24, 28, 32, and 36 are in. Now, the leftovers for my multiples of 4 are 20 and 40. And for B, we've got 22 and 30. I can now clearly see the ones that I've not crossed off my main list. I've got 26, 34, and 38. So they will go into the rectangle section. And that is us done. We're then being asked to find the probability that this number is in the set A, and then we've got this symbol B. Now I see this as U for united, A and B together. So it's all of the numbers in all of the sections. And we've got 1, 2, 3, 4, 5, 6, 7, 8 out of a total of 11. Please remember, when you read probability, you need to be thinking fractions. Our answers are always fractions unless the probability question itself has given you some information in decimals. So you must be thinking fractions when it comes to that word. Okay, now I do quite like this type of question. It's not massively common. I appreciate that. The reason that I like using it and making sure that my students see it is because I don't want them to lose the formula triangle for regular polygons. You can sometimes get around a regular polygon question without it, but honestly, it's the best thing ever. You read that word regular, it triggers this triangle. 360 at the top, side or sides, I just don't have room to write the whole thing, and that X is for exterior angle. Okay, like I say, there are some instances where you can get by without needing this, but this is an example of when you absolutely cannot. If you don't have that up your sleeve, you're going to really struggle to answer this question, and that's why I throw this every now and again at my students, because it's forcing them to realize just how important this triangle actually is. Now, this is a polygon. I don't have the entire polygon. Obviously, it must keep going and it must join up, and it's got a certain number of sides. I just don't know how many. If I knew the exterior angle, I would just be able to divide it into the 360 and find my sides. This is the interior. The exterior sits on a straight line. So all I need to do here is 180, take away 144, which is 36 degrees. And then I take the 360, divide it by 36, and I've got 10. I'm being asked the name of the polygon, so it's a decagon for a 10-sided shape. So a fairly straightforward one and a fairly nice regular question as far as the numbers go. At this stage in a past paper, they're usually trickier, aren't they? But really threw it in there to get us all aware of this again. Really massively helps. Okay, there are 8 boys and 12 girls in a class. The class has a test. The mean mark for the class is 36. And the mean mark for the girls is 45. And we've got to work out that mean mark for the boys. Now, it's pretty obvious. Mean is the key word here. And how do we find the mean? We add everything up to get a total. And then we divide that total by how many are there, all the numbers, let's say. That's what equals the mean. So even though when we talk about the mean, we think about it in the form of a sentence, add them all up and divide by how many are there, the reality is it is a formula. You add to get a total, you divide by how many are there, and you get your mean. And that is what you're going to use to make this a very easy question to answer. So the mean mark for the class, there was a total for the class. I don't know what it is, but there was a total. And when it got divided by 20, because that's how many are in the class, the boys and the girls together, it gave a mean of 36. Now, if I get my t on its own, by moving the 20, it'll land as a times. It will tell me that the total for the class is 720. I'm never going to know all the individual marks for each student, but I can work out some totals. I'm going to do the same for the girls now. So there's a total I don't know, but when it got divided by the 12 girls, it gave an answer of 45. So I rearrange and I need to times through by 12. Now, this I'm going to need to do a little bit of working out. So the total for the girls is 540. Now, the reason that's significant is it means just by taking away the girls from the entire class, I can get the total for the boys. So 720 take away 540 will give us 180. So 180 divided by the number of boys is going to give us that answer. Now I'm going to use my bus shelter to help me here. Now, when I get to that point where I'm putting a remainder and it's not really attaching itself to anything, that's when I know to add my 0 and add my point. And then 8s into 40 go 5. So the mean mark for the boys is 22.5. Okay, we have a train company increasing its ticket prices by 5%. This 5% increase adds £8.56. And you've got to work out the new price for a ticket from London to Birmingham. So what we know from the story is that there was an original price and £8.56 gets added to it to create the new price. So that's one way of looking at that. I have got to work out what this original price was. Now, it's really easy to miss this in the question. It's increasing by 5%. This increase adds. This increase of 5% is 8.56. And that's how I need to view this. 5% is worth £8.56. The original is me getting all the way to 100%. So I'm going to double. That's giving me 1712. And then I can just times that by 100. Sorry, times that by 10 to get to 100. And timesing by 10 is just moving that decimal point one place. You could have done 5, you could have taken that 5%, multiplied it by 20 and gone directly to 100. Again, there's no perfect way. It's just the way that you see it. So the original ticket price was £171.20. Our 5% increase was £8.56. So the new ticket price is £179.76. Okay, so that's the end of the crossover question. So the sort of mismatch of question numbers has ended. We're now on question 9. Everything is going into grade 6, 7, 8, and 9 from here. So we're being asked to find the interquartile range of the marks that we've been given. First thing that we're going to need to do is put them in order. And then we're going to work on finding where the middle is. So we're going to get the median first. We want to get to the quarters. So being able to see where the middle is will be really helpful, but we don't want to start scribbling through everything. So instead of crossing off, which is the kind of norm, I'm just going to underline, and I'm also going to do it in chunks so that I can just get it done a little bit quicker. Okay, that is my median. Now I'm going to cross off, because if I find the middle of this 50%, I will find my quartile. So the range would be 14 take 4, which is 10. Okay, so we're being told that t is directly proportional to the square of p. Now this should trigger our constant of proportionality, which is given or represented by the letter k. So t is equal to k times whatever they're talking about, because it's directly proportional. So it's the square of p. When t is 540, p is 3. Now we're going to work through this so that we can work out what k is. Now 9s into 54 go 6. So we've got 60 for our k. We're trying to write a formula for t in terms of p. So we're going to return to this and replace the k with the value that we've found. And that's it, we're done. Okay, so we've got a 2-in-1 a fraction question. What we've actually got is BIDMAS with fractions. So I'm going to be doing my multiply first. And I'm going to be changing my mixed number into improper. And again, changing that mixed number into improper, I would get 13 over 5, and I'm on my take away stage. Now it does say to give my answer as a mixed number in its simplest form. So 20s into 39 go 1 with 19 over 20, and that would be my final answer. Okay, so Brett records the number of texts he sends each month. In July, he sends 736 messages, which is 15% more than he made in June. So what we know is that we have an increase question with 15%. A 2-tick question is original times multiplier equals result. We don't know the original. That's what we're being asked to find out. That's June. But it got multiplied by 1.15 to give 736. So our problem is a division. So we're going to set this up into our bus shelter. 736 divided by 1.15. Now that's a problem. We don't want a decimal. So we're going to times by 100 to get rid of it. That's what we've done there. But if we multiply that, but we've also got to multiply this part so that we keep everything perfectly balanced. So I'm going to rewrite that to give myself a bit of space. And yes, I'm going to need to work out a little bit of the 115 times table. I'm going to stop there. I don't know how many I actually need. when you first think I've got to write out that times table, it's oh no. But then actually, as you're doing it, you realize it's not that big a deal. Now we've got to we obviously can't get into 7, we can't get any into 73. So we're going to be working directly with 736. So although I've stopped, I can see I really do need to go again. And I can also see there would be no point in going any further than that. So I can get 6 in to my 736, and that would leave me 46. 46 is here, creating 460. I can see that goes exactly 4, and then bring your 0 up. So the answer is 640. And the maths wasn't actually too bad in the end. Okay, so the first part of this requires us to draw the graph of y equals 2x plus 1 on the graph that we've already been given. Now, there's a couple of ways that you can do this. One way would be to set yourself up a table. Now, you only need a few coordinates. It's not like you're completing a table of values for the examiner. You're just doing this to help you position the straight line in the correct place. So if you're doing it this way, just choose a negative, a positive, and use the 0, and you'll have enough to line your ruler up next to. We have the rule 2x plus 1. So we'd be doing 2 times whatever x is, and then you add that 1. So for -3, you have got -5. For 0, you would end up with 1. And for the +3, you would end up with 7. There is an alternative way, which is the intercept way. That would be to mark the coordinate where it crosses the y-axis, which is 1, and then do your gradient of 2. So along 1 on the x-axis, up 2 on the y. And you keep repeating that. And that's just a slightly different way of doing it. The length of your line doesn't matter in respect to marks, but what it must do is go through the curve. Because for the second part, we are going to use our diagram to solve the simultaneous equations. That is where they are crossing. So I've got coordinates where the 2 lines cross, and then I would literally just write my solutions. So when x is -1, y is -1. When x is 2, y is 5. Okay, this next question, which is asking us to make b the subject, is quite a tricky rearrangement. So let's just go through it step by step. First thing we want to do is get rid of that square root. So I'm going to bring it across and it will land as a squared. So I've got x squared equaling b plus g all over bf minus d. Next thing I want to get rid of is this divide. We don't want a denominator. So all of this will go across and land as a times. So I've got x squared there already, and then my bf minus d lands next to it. I want all of this to be multiplied by the x squared, which is why we have the brackets. And this equals b plus g. Now I'm going to expand the brackets so that we have availability on all the different terms. So we've got bfx squared minus dx squared equaling b plus g. And now we're going to get the b's together on one side, and anything that doesn't have a b will go over to the other. So this b will come across and it will land as minus b, and all of this will go to the right-hand side, landing as a positive. That then looks like this. Now, I've got the b's on the same side, but I do still have 2, and I only want 1 if I'm going to make it the subject. So this is where we can factorize. If we apply that skill, we can get the b factored out and on its own. And now all we've got to do is take all of this to the other side. It will go from multiplying the b to dividing this. And that is our final answer. Okay, so we've been given a sector. A region of it is shaded. We're told the angle AOC is 60. It's marked on for us. and we can see that the edge is 12x. And we've got to write an expression for the perimeter of the shaded segment. So I'm going to highlight that on my diagram. So those are the edges that I'm going to need to work out. I have the arc of the sector and I have an edge of the triangle. Now, the first thing that we want to clock is this 60-degree angle. If you've got a triangle with a 60-degree angle, the other two will also be 60 degrees. We have an equilateral. So I now know, just because it's an equilateral triangle, that that edge there is 12x. So the main problem that I have is finding the arc. It's a fraction of the circumference of the circle that it came from. And I've got a sketch there of that circle so that you can kind of see how it works. This edge here is going to be the radius, and I just want that much, not the entire circle. Now, the circumference is pi d. The diameter is all the way across, so that would be 24x. And then we've got that pi being multiplied to it. But remember, I only want a fraction of that. I want 60 degrees out of the 360. So that gets multiplied in. I'm going to cancel my fraction to a sixth because the numbers are smaller and easier to work with. 24 divided by 6 is 4, leaving me 4x pi. And that is an expression for the arc. And we must remember we haven't finished. We must add on the 12x as well. And then our final answer would be just to put that together clearly. You could factorize that if you wanted to. It doesn't say anything about pi in the question. It's a non-calculator paper. So I would just keep that in as part of my expression as well. Okay, so we've got 10 sweets in a box. We've got red and yellow sweets, and 3 are being taken randomly from the box. And we've got to work out the probability that Skylar takes at least 1 sweet of each colour. So before we go into a massive tree diagram, which will work and is absolutely fine to do, you could just start off considering some of the combinations, just so that you can be clear of what we're talking about. So you could pick a red, a yellow, and then a red, and you have got at least 1 of each. You could get red, red, yellow, and obviously you can have a lot of different combinations. The only combinations that don't get a tick would be if they were all the same. Red, 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 and yellow, yellow, yellow. So a far more efficient way to approach this problem wouldn't be to draw the entire tree diagram, calculate all the possible combinations and add them together, but to actually work on the ones that don't answer the question, because there's a lot less work, and then you can make your adjustment at the end. So that's what I'm going to demonstrate. To take the first red, you have a 7 out of 10 chance. The second red would be 6 out of 9. And when you take the third one, you would have 5 left out of 8. And these get multiplied. Multiplying that across gets you 210 over 720. We are then going to do the same with the yellow. So there were 3 out of 10. Then there were 2 left out of 9. And then there was 1 left out of 8 to give us 6 over 720. Now you add those, which would give us 216 over 720. But that's the probability of getting them all the same. It's the opposite of actually what we want. We know that probability adds to 1. So what we want is the fraction that would add to this to create the 1. And that would be 504 over 720. If you cancel, that's absolutely fine. It hasn't asked for that. We don't generally cancel. But if you did and you got all the way to the simplified fraction, it would be 7/10. Okay, so histograms are an almost guaranteed topic. We are going to see it on one of the 3 papers. I've popped it in here because it's creeping more and more into non-calculator papers. So obviously I can't guarantee it being there, but if we're prepared and ready for it, then we aren't going to be caught out. So as soon as I realize it's a histogram, I would be wanting to draw my formula triangle, which is frequency, class width, and frequency density. And then it's there to help and remind me if I need it. It says that 160 adults ran and that the information is in our histogram and we have to complete it. The first line, all of the adults ran at least 5 kilometers. So I would mark that on the histogram ready. That's the bar I'm going to need to complete. None of the adults ran more than 55. So check that end. Okay, that is the last of the adults done. So I don't need to worry about this side. And we're being told that 28 ran between 15 and 20. So we have 28 represented in that bar. So what I've got is the frequency of 28 and the class width of 5. And I'm going to use that to help me find my frequency density. So we're going to be doing 28 divided by 5. Now 5s into 28 are 5 with 3 left over, and 3/5 is 0.6. So I have got 5.6. And I can go to the graph and I can mark that on. This enables me to get the scale. Now I know that there are 160 in total in the diagram. So what I want to do is I want to work out the frequency of this bar and the frequency of this bar. That way I've got the number that have already been represented and I can work out how many I need to represent in this bar. And again, we're going to use our formula triangle to help us. To find a frequency, we're being told to multiply the class width and the frequency density. This bar here has a height of 6.8 and a width of 15. Now, the way that I would do this is I would do 6.8 times it by the 10, which is 68. I'd then half that and add it together to get my final answer of 102. The next one is 0.8 times 20. 2 8s are 16. Now I'm going to add all those totals together. Don't forget the 28 that we were given, and that would be 146. Take that away from the total. That gives us 14. So we just need to know the frequency density. So we've got the height. Frequency density is your frequency divided by your class width. Our class width is 10, which is going to be 1.4. And we will draw to a height of 1.4. And we have completed the histogram. Okay, in this question, we've got a recurring decimal being added to a terminating decimal, but they also want us to give our answer as a mixed number in its simplest form. So we are going to have to work on this so that we have a fraction at the end. Now, there's a couple of ways that you could do this. You could work on this decimal, get that fraction, turn this into a fraction and then add them. Or, and the way that I'm going to demonstrate it, is we could add these first and then start working on turning it into a fraction. So we've got 0.1666 recurring, on and on it goes. Write down some of it so you can see it clearly. And then we've got 2.4 to add to that, giving us 2.5, and then that 6 repeating on and on. This tells me I've got 2 whole and this decimal section, which I want to turn into a fraction. So we're going to set it up. That's the fraction I don't know. It equals 0.5666 on and on. I'm going to times through by 10 because the recurring part is recurring every place value. And then I'm going to take away an x. I'm going to get x on its own by dividing through by 9. And obviously I don't want that decimal there. So we're going to times through by 10. And you do that to top and bottom. So I know that my fraction is 51/90ths. I also know it needs to be in its simplest form. So I'm going to divide now through by 3. 3s into 51 go 17, and 3s into 90 go 30. My final answer has to include that whole part that I kind of ignored whilst I was working on the decimal. So our final answer is 2 and 17 over 30. In this question, we're being told about a curve that has one minimum point, and we have been given the coordinates of that point. That curve is then being translated. When you have a value in with the x, then it's the x coordinate that will be affected. There will be a horizontal translation. So we've got the minimum point. When it's a horizontal translation, we do the opposite of what we see. So we're going to be adding 3 to the x coordinate to give a final answer of 6 minus 2. When it's away from the x, it's a vertical translation, and it moves in the direction that we're given. So it's a positive 6, and this acts on the y coordinate. So when it's away from the x, it acts on the y coordinate, giving us 3, 4 as our final answer. Okay, so for this question, we've got to work out the ratio of G and H. At the moment, we've got G, H, and E in the information that we've been provided. So we can't lose sight of the fact that there is currently an E here, and we don't want that. Now, you can either replace the E with the 2H at this stage, or you can do it a little bit later down the line. I'm going to do it a little later down the line. I just don't want to mess with it too early. So I am going to move these denominators. I am going to multiply through by 4 to get rid of it on this side, bring it across as a times by 4 on this side. And then this is going to work sort of simultaneously by multiplying through by E minus G, we will be multiplying. And this is how it looks when you finish. Okay, so that's me doing it as in a literal way. I've moved the 4 across and the E minus G across. Multiplying through by 1 isn't going to change anything. However, this is landing and getting multiplied by 4, which will have a more significant outcome. I've now expanded those brackets, and at this stage, I am going to replace my E. Now, E is 2H, we've been told that. And now I'm going to rearrange to get my H's together and my G's together. And then my ratio is 5 dot dot G. So not overly complicated as far as the substitution goes. Knowing how to approach those questions, though, can be pretty tricky. Okay, so this is a top-end indice question. The first thing that they're testing really is, do you understand that indice rules will only work when the base numbers are the same? And at the moment, we've got a base number of 2, of 8, and of 16. So we can't use any rules whilst it is in this particular form. So I'm going to change everything into base 2, as ultimately that is what I'm trying to work out here. I'm going to get rid of the root 2 and represent it in its equivalent form with the fraction 1/2. I'm going to get rid of the 8. 2 to the power of 3 is 8, so that's the equivalent to 8. But remember that our 8 is being raised by the power of 3. And this is all over, and we're going to repeat the same thing. 16 can be represented as 2 to the power of 4, and then that is to the power of 3 over 2. Now I'm going to use my indice rules. So I've got 2 to the half divided by 2 to the 9 over. Now this fraction will multiply in. 4 3s are 12, divided by 2 is 6. So I've got 2 to the power of 6. I can use my indice rules on this division here, and I've got 2.5 divided by 2 to the 3. And again, it's a division. So we are going to use that rule of take away. 1/2 take away 3 is 2 to the negative 2.5. So we've worked out the left-hand side to give 2 to the negative 2.5. You may have stayed in fractions, which would have been 5/2. And that is our result for n. N is equal to -2.5. Okay, we've got a straight line. Let's got the equation 5y plus 2x equals 7. We're being asked to find the equation of the line that is perpendicular and passes through coordinate 5, 3. We've also got to represent our answer in a particular form, so we need to be mindful of that when we do get to the end. So the first thing I need to do is rearrange this equation so that I can work out its gradient. Now the gradient is sitting in front of the x, which is -2/5. So the perpendicular gradient is the opposite sign, reciprocal. So I can see that my gradient for the new equation that's perpendicular is 5/2, 2.5. Now we're going to use the equation formula. Now you don't have to do it this way. You may not have seen this before. It's very neat, very easy to use. I'm going to be substituting in my gradient, and y1 and x1 are the coordinates that I've been given. And I just start expanding. Now, at this stage, and you don't have to do it at this stage, I'm just going to do it because I actually believe it will be easier if we do it at this stage. It says that we have to give our answer in a particular form where A, B, and C are integers. And I've got fractions here. So I'm going to multiply through by 2 and just get rid of those fractions at this stage, because that means that I will have less fraction work to do because I'll already be in integers. You have to remember that you're multiplying everything by 2. So that would give us 2y minus 6 equaling 5x minus 25. So now we're going to work on getting this into the format. Now they want the x and the y together on the same side, and preferably the x first. So what I'm actually going to do is I'm going to take the y, move that so that it's joining the x's, which will give me 5x. If I land in there, it will be minus 2y, and I've still got that minus 25, which is going to come across. That will land as positive 25 to give me 19. So writing it clearly in the correct form, I would have 5x minus 2y equaling 19. Okay, our final question, and it is definitely a biggie. We've been told the area of the triangle, and we've got to work out the size of the angle. So this question is really going to be testing our surds. Now, the area of the triangle can be found on the formula sheet, which is a half AB sine C. So let's start putting in what we know. I'm going to tidy up all of this. And then I want to get that in its simplest form. Now, root 60 will split to root 4 and root 15. You've got your square number there to give you 2. So it tidies up to 2 root 15 over 4. And then we can cancel the integers to give us root 15 over 2. So now let's write down clearly what we have. We have root 15 over 2 times sine, and I'm going to change it to x now because that's the angle that we're trying to find, equaling 3 root 5 over 4. I'm working to get x on its own, so I'm going to move this across. It will land as divide by root 15 over 2. And what we're looking at here are two fractions. So we're going to be applying our keep, change, flip method. So I've got 3 root 5 over 4 times 2 root 15. When I do this, I end up with 6 root 5 over 4 root 15. Now I need to rationalize the denominator. So we're going to be timesing through by root 15. That is going to give us, on the numerator, 6 root 75. And on the denominator, it's going to give us 60. Now, our integers will cancel. And now we're going to work on our surd because that will simplify further. Root 75 will go to root 25 and root 3. Root 25 is our square number to give us 5. So what we've now got on the numerator is 5 root 3 all over 10. That simplifies to root 3 over 2. We've got sine x equaling root 3 over 2. So now I just have to think about my exact trigs. And you may remember it using your finger trick. It may be that you write down your own table, but the final answer is sine 60. That's what gives us root 3 over 2. So x is equal to 60 degrees. I hope you have found this paper really useful. I think it's nice to have brand new questions to practice against. As I believe I said at the beginning, it is a mix of key skills and applications, things that we might see, but obviously we don't know how they might come up. Good luck with paper 1. We will be putting out things for paper 2 and paper 3, so keep an eye on the channel, and I'll look forward to seeing you in our next videos.